It's all good. All right, tonight's chapter 13, network management. So we'll finish up this chapter, and then next week we'll move back to the beginning of the textbook, and I think start up with chapter 2 is the next one. So outline, we'll talk a little bit about an introduction. Why is network management important? What is network management, for example? This book covers some of the main concepts with respect to network management, but it doesn't cover them all. For example, it doesn't cover change management, which is an important concept. So I'll talk about that for just a little bit when we get in here. But it talks about organizing the management function. Spends quite a bit of time talking about configuration management, which is a big deal. And it's something that's really troublesome. And if we don't do a good job of that, we have to incorporate change management. The reality is we have to manage both of those together. We'll talk a little bit about performance and fault management. Finish up with end-user support and cost management. So these are not all the various functions that a network manager has to take care of. But these are some of the main things, some of the most important things that a network manager will take care of. Now, why do we have the network management function for networks? Because we spend a lot of money on it. Back in the early days of computing, when we had mainframes, for example, it wasn't that big a deal. Mainframes were relatively easy to manage. Not a lot of people had access to it. There weren't a lot of upgrades, so it was the pace of change was much slower. But over time, we've spent a lot of time pushing out PCs, pushing out networks, insisting that we connect to the internet, for example. And so as a result, we end up with a much larger investment that's out in the hands of a lot of different types of people. People that understand technology, people that don't understand technology, and everybody in between. So it creates a need for managing how that hardware and software gets pushed out to various users, how we go about supporting those various types of users that are using our systems, etc. Lack of planning. If we don't do a good job of doing it, we spend a lot of time what's referred to as firefighting, which means we spend all our time going out and fixing the latest problem. Somebody calls up on the phone, we don't worry about documenting it or anything like that. First thing we do is we run down the hall wherever the problem exists, and we try to fix it. And unfortunately, with a poor design, if that's what we end up doing, that's all we end up doing. We never get a chance to develop a system to properly track problems. Maybe the real problem is not, this individual's problem is that it's very small and very isolated. Maybe the reality is that particular hard drive that failed on for that particular user. Maybe that's a hard drive that we bought all across campus. And that hard drive, that brand, that model has a problem. If we don't document that and keep track of that type of information, we have no way of knowing that there's a problem with that particular type of hard drive unless somebody happens to put two and two together. So we really need to spend a lot of time thinking about how we're going to go out managing our network, and that'll help prevent us from having to go out and fight fires all the time, and instead concentrate on trying to make sure that our network's running at peak performance and provide services to our users that they really want and that they can use to do their jobs better. Main areas of network management function: configuration management, performance and fault management, like I said earlier, change management that they don't really talk about, end user support, cost management. Those are some of the main areas that a network manager is going to have to deal with. So this is what I was talking about earlier, that you've the reason you've seen it occur, this function, where this management function has come from, is because when you had a limited number of people utilizing mainframes for computing power, management function was really pretty simplified. I mean, you either bought the stuff or you didn't. The number of people that you were supporting was very few. Those people tended to be very technically inclined, so there wasn't a lot of need for end-user support. So the management functions at that time were very simplified. It's a different world when we push out 1,000 machines to a variety of different types of users. The focus of integration has also tended to change things. Not all LANs use the same architecture. That just complicates it. That requires some type of a manager. It creates a situation where you need some kind of a manager that much more, because we have different types of hardware that we're trying to integrate together that can be so that they can be able to talk to each other and communicate back and forth. The more complexity that we add to a network creates a situation where we need some type of proper management function that much more. Keys integrating them into one organization, both LAN/WAN or web and WAN managers to recognize that they no longer have total power. It means they don't operate in isolation. When you ran a mainframe, you kind of had the keys to the kingdom. It was your mainframe. If somebody wanted access to it, they had to come and ask you for permission. They had to convince you that they had a proper need to be able to use that mainframe for whatever purpose they were needing it for. But today, as a network manager, you have to realize that you're operating inside of an organization that has organizational needs. Your customer is not the same customer as the organization's customer. The organization's customer is purchasing a product or service from the organization. As a network manager, your customer is the users inside the organization. You're serving them with computing power. You're providing them with network access, with email access, web access, those types of things. And so you have to make sure that you have to understand that you're working to appease your customer. You're working to make sure that they have the services, access to the various services that they need, such as email and web, etc., disk storage, and things like that. Sometimes you have to make decisions that aren't in the best interest of your network. Why? Because it's not your network. It's the organization's network. And if they happen to have a need where people need to share passwords, even though that goes against every best practice in every organization's handbook, maybe you have to say, okay, well, in this particular case, because the organization requires that, we're going to allow that. A lot of the ways to avoid problems is to have some kind of a written document that's going to tell you and your staff, as a network manager, you and your staff, what's your real mission inside that organization? What is your goal of providing services to your users, to your customers? So define the purpose of the networking department. Talk about the operational philosophy, long-range goals. How are you going to go about your long-range goals in terms of changing through your various systems? How often are you going to try to change through your hardware? How often are you going to look at new operating systems? Are you going to, what's your operational philosophy with respect to developing new software versus using off-the-shelf software? So it's good to kind of have an idea for the IT department as a whole, as this is how we can tackle problems, so that when you're faced with a new issue, you kind of all already have a mindset of how you're going to address that particular problem. So a lot of times you want to develop individual procedures to implement these policies. For example, think about change management, or think about data retention. If you've got a data retention policy or a need for a data retention policy, you probably don't want to just create it and throw it out there. You've got to have some kind of a procedure to implement that. Not only in terms of determining how long you need to hold on to the data, but how are you going to communicate that to users? Because just because you have a policy, if you don't tell the users that you can't delete email for 6 months, I guarantee you the email that you need is going to get deleted, because that's just how it works. So you have to have a policy for going through the process of not only developing various policies, but also disseminating those policies to the various users that are going to be governed by them. Any questions so far? Another issue that kind of mucks up the work a little bit is the complexity of networks. We talked about that a little bit earlier, the complexity of our systems, creating an additional need for some kind of management function. Well, the integration of voice and data is certainly adding to that complexity. Years ago, we typically, as an organization, we would maintain 2 separate networks, a datacom network and a telecom network. And they were run by completely different departments. They had different wiring. They were really kept separate. But you're seeing more and more often that a lot of these networks are being combined. Why? It costs less in terms of cabling. We can reduce our staff because we don't have to run 2 completely separate departments. So it just makes sense. But at the same time, because we're running data and voice communications across the same network, it adds to the complexity of some of our configuration. Speaking of configuration management. Management of the network's hardware and software configuration. Keeping track of what hardware we have, what software we have, and how it's all put together. Documenting that configuration and ensuring that the documentation is updated when there's a change in the configuration. There's their brief little reference to change management, essentially. The problem with configuration management is it's a point-in-time snapshot of the network, of the various pieces of the network. The reality is the network is not static, it's dynamic. It's always changing. It has to. If for no other reason, the business environment changes. The business environment changes, that changes our needs as an organization of what we need that network to be able to do. For example, you look at airline prices and corporations looking for money to try to figure out, or looking for ways to try to save money. And instead of having people fly all over the country or fly all over the world for sales meetings or various other types of meetings that they might need, they want to do what? Teleconference, right? It's a good way to shift some of those costs. Well, that changes the demands on our network. That's a business need, a business change in the environment that's impacting our network. So without any changes in the network, we're going to be impacted by environmental changes. And there's a lot of other types of pressures that impact the need for change in our network. Configuring network and clients, adding and deleting user accounts, new user additions, and categorize. So we need to have some way of documenting how we're going to go about doing all that. That's what configuration management is about. Understanding what that process is of adding new users, having things like a format that we create usernames in. For example, if you're trying if you've got a help desk that's trying to provide support for various users, you want to have some kind of a naming convention for usernames. Why? Because if you have a different naming convention for various users, if somebody calls in for help desk and they try to ask help, somebody asks, what's your username? I don't know what my username is. That happens frequently. Okay, well, if you have a naming convention, as a help desk technician, you can start to help that user identify what their username is. Without that convention, who knows what it could be. So naming conventions and things like that are very important. With respect to configuration management, you also want to monitor the update of software on your clients and servers. Why? Because again, it's the same thing we were talking about a minute ago. Our network is dynamic. So just because we install the various software on our system today to get it up and running and to serve the needs of our users, patches come out all the time. Updates come out all the time. That's going to change our configuration. We have to document that so that, one, we know whether or not this system needs this patch or not, and two, once it's gotten that patch, that we know that it's been patched, we don't have to come back and patch it again. That's an example. There are some things that can help make that process a little bit easier. Electronic software distribution. Everybody has their own specific name for it. For example, Novell has a product called Novell Application Launcher. It's basically software in which you have a server side and you've got clients that are loaded on the various clients. And it allows a network administrator or a network manager to automatically push out software to those various clients. So when a patch comes in or a patch becomes available or a new software becomes available, maybe a new version of Office or something like that, you can use this software to push it out to all clients, to push it out to specific clients. At the next time it reboots, immediately. It's very customizable as how you want to do that. It gives you a couple of advantages. It allows you to, one, not have to physically go to each machine. If you got 5 computers in your network, it's probably not a big deal to go apply patches. But if you got 5,000, that takes a lot of time. If you've got something like this, you can automatically push that out to all your clients at the same time, and it really helps to facilitate that. At the same time, it tends to document that patch has been applied. So that's a good kind of side effect. You get a log back from most of these various forms of software that says, yes, that patch was successfully applied to this particular client at this date and this time. So it automatically produces documentation for you to know that these are the computers that received that patch. These are the ones that are missing that patch that we need to go visit physically or reboot them remotely or something of that nature. You need to look into those further. But you can automatically eliminate all the ones that did receive the patch. Any questions?
Could you give me an example of a name of this? Because we were talking about this at work, of an ESD.
Novell Application Launcher. Microsoft has version 2 as well that they use here, but I'm not sure what the name of that is. The one I've used before was Novell Application Launcher. And it's a nice little package. Like I said, you can use it to push out patches. In a larger networked environment, essentially what happens is you tend to have some custom installations. You tend to have software that has kind of been installed but doesn't necessarily play nice with other software installations. So as a result, the network admin sometimes will go in and modify the registry to be able to make these two pieces of software work together on the same system. That's great until you have to apply a patch. A lot of times a patch will break the modifications that you've made to a registry. So in a large networked environment, what you usually end up doing with your various clients is you turn off automatic updates. Personally, I don't like that, but in that type of environment, you kind of don't have any other choice. So what happens is, because you've got automatic updates turned off, your network admin now has to go through the additional process of manually downloading that patch to a test machine, testing that patch, first identifying if that patch is going to affect your software, because it may or may not. If it doesn't, you don't worry about it, end of the story. If it does, now you need to apply that patch to the test system and see what effect it has. Test the system, make sure that the various software packages that are on that system aren't impacted, that they function as they're supposed to. Once you've verified that it functions as it's supposed to, you can then load it into your ESD and have that push out to your various clients because you've tested it. Now, most of the time, like I said, you'll end up with a large portion of your machines that will go ahead and apply that patch, but invariably you'll have a user that was in the process of rebooting. There'll be some kind of a configuration error somewhere, and so you'll have some machines that weren't patched as they should have been. But usually if you can get 80 to 90, 95% of your machines taken care of, you've really limited your scope. You can focus on just a few. So it's, not only does it serve as a big time management tool, it also helps to automatically document these were patched, these weren't. We go physically address these. Good question. Documenting configuration includes information on the network and hardware and software. So what's the physical hardware that we're using, the various switches, the brands, models, etc. The software that we've got installed on our various machines. In a lot of cases, it's pretty simple. If it's just a basic workstation, we may have nothing more than a browser and Microsoft Office. If it's for an architect or something like that, we probably have some CAD software. But we need to document all those different types of software. Hopefully, and we'll talk about this a little bit later on when we get into the cost side of things, hopefully we can really kind of standardize on a few configurations. It helps on the maintenance side of things, helps on the cost side of things. It costs us more in some cases in terms of licenses up front, but those are typically one-time costs. The maintenance side of things is a recurring cost that happens over and over again, and that's where we can tend to save money. We want to document our various users and various application profiles, document our network, the cables that are used, where those cables are run, things like that. Documenting the network hardware, typically done via a set of diagrams. It may be a picture of your various racks in your organization, the layout of the servers versus the UPSs versus switches, etc. And it must be supplemented with details on each device. You want to know what the brand was, what the model was, what the serial number was. You probably want to know what the warranty period was too. This stuff isn't cheap. If you can get it covered under warranty, you want that. You might want to link to, maybe you got in an appendix images of the receipts for them. If you got a link right there, boom, you can get your receipt real quick. It's under warranty. You've got a copy of your receipt. You're good to go. Support phone numbers is good to have there as well. So you've got this document that has all the pertinent information about this particular product, where you bought it from, etc. So then they give you an example. I don't know that that's the best example. It's not really, I don't really think it's all that user-friendly to read, but they did give you an example at least. Documenting software includes information on the network operating system. So what version of the operating system are you running? What service pack have you got on it? Various patches that are applied. Are there any special network software versions, release dates, etc.? Let's see, documentation of user and application profiles used to identify access rights to files and directories. So you kind of want to know the directory structure that you're going to allow users access to. Why? Because if you have a user that has access to a directory they're not supposed to, there's a configuration problem. You probably need to fix that. Other network documentation, manuals for hardware, software, standards, operations, vendor contracts, and licenses. That's stuff that you'll need later on. Usually you don't think about it up front until there's a problem. If you have a UPS that fails or something like that, you need to be able to contact your vendor to get them to replace it if it's under warranty. Some other documentation that you'll probably want, they don't talk about that type of documentation a lot right here, but performance and fault management, which we'll talk about in a second, but maintenance guidelines. How often do you need to go through and check the batteries on the UPSs? How often do you need to do various other types of things for your network? Disaster recovery plans, user support, and cost management. These are all things that you need to document. So performance and fault management. Anybody heard of Peter Drucker? Nobody's heard of Peter Drucker. He's I think he's a Harvard professor. He was, and he's basically he's I don't know. He's kind of a hard person to nail down and really describe thoroughly. But he's a business consultant. And he's written a number of books on how to run businesses, the most efficient ways to run businesses, etc. And one of the things that he's very famous for saying is that in order to manage something, you have to be able to measure it. Well, you don't know how your network is running unless you measure it, unless you look at how efficient it's moving data across the network. And that's really kind of the purpose of performance management. Tie that together with fault management because they're both very closely related. Essentially, one's before the problem, one's after the problem. Performance management, ensuring the network is operating as efficiently as possible. So it can crank those ones and zeros through the network as efficiently and as fast as possible. If it's not, maybe there's a problem. If it is, everything's great. But like we said earlier, it's a dynamic network. Needs change. If we go to video conferencing, that's going to consume more of our bandwidth on our network. We need to be aware of that. How much more bandwidth is that going to tie up? Fault management is kind of on the after side of things. That's if we've got a fault, now we need to fix it. But we need to know what to fix. Fault management helps us to identify what's failing sooner. Possibly even before it actually fails, completely anyway. And that's the idea behind fault management. In both cases, you got to be monitoring the network. If you're not paying attention to what's going on, you're not going to know about a fault until the end user calls you on the phone screaming at you. As far as network monitoring, you've got a number of tools that are kind of at your disposal, and they don't really go over it in too much detail in the book, but essentially you've got a couple of different parts. You've got, if it's a managed network, you've got on your various devices, you've got what's referred to as a, my mind just went blank, as a, well, not a client, but a piece of software that's loaded onto the individual client, or onto the individual computing pieces, switches, routers, network cards, etc. And what will happen is that little piece of software will keep track of the throughput, how many packets are going through it, how many packets are getting dropped, information about the performance of that particular device. What will happen is that will communicate back with a piece of software back in your network operating center that it basically serves as a dashboard and allows you to keep track of all your various devices that are on your network and how they're performing. So what will happen is when you start to get a notification from one of those devices that says, hey, we're seeing a lot of traffic on this particular node, or we're seeing a lot of dropped packets, that's a clue to you as a network manager or somebody in the support staff to say, hey, we need to look at this a little bit closer. Do we have a network card that's failing in that particular area? Do we just happen to have unusual demand at this time because there's something going on, a meeting or a convention or something like that? But it's a way to provide insight into what's going on in the wires of your network from a network manager's perspective. So basically it's going to collect all kinds of operational statistics from those various devices. It'll keep track of physical network statistics. Some of the information is going to come from modems that are on the network, multiplexers, routers, switches, etc. Some of the information that you can get back, things like user response time, traffic volume on a specific circuit, source and destination of various packets, etc. So there's a lot of information that you can get from some of these types of software. On the failure side of things, requires developing a central control process for problem reporting and troubleshooting. Let's see if this is. So basically, they're starting to set you up for this very next slide, and we'll talk about this for just a second. But maintain a central phone number for your users to report problems. Your users are not their job is not to use the computer. The computer is a tool. That's all it is. So when a problem pops in, so they're not constantly thinking of, this is the help desk number, this is who I should contact when there's a problem. If they know that by heart, there's a problem. That means there's so many problems on your network that they know it by heart. That, or they just like talking to people, tech people, which is cool. At the same time, you've got to have that number where these people can easily get help when they need it. And that's the idea behind this. You also want to establish a central troubleshooting group. Basically, you want some place to go where, this is on the support side, where they can talk about all their problems. Because, especially in a network like we have here on campus, there are local area networks all around campus. Not everybody controls the same things. The people at Blackboard don't necessarily talk to the people in some of the other departments, but they should, at least to a degree. And that's what this is about. Because at a certain level, things that occur in one part of your network impact things that happen in other parts of your network. And so periodically you want to talk about some of those problems. Things that we're planning on an upgrade. We're going to expand the campus this way. We're going to install this many PCs over here. What impact is that going to have on our bandwidth as a whole? So you need to be able to talk from various departments, technical departments within an organization, and share your problems, because there's a good chance that a problem that your department sees has something similar has been seen somewhere else, and a lot of times you can work through those problems a little bit easier. Detecting and reporting network problems, typically from a couple of different sources. Sometimes the help desk will find a problem all on their own, and that's great when they can do that, because you're not having to listen to a user scream at you. The user, hopefully if the user finds it first, they're kind, they're benevolent, they're not yelling and screaming. And that's usually the case, but every now and then you get a user that's just not the nicest person in the world. And then the other way is, the preferred way, is through those managed devices that we were talking about. That it screams at you and says, hey, this circuit is really busy right now, there's something wrong, something's failing. So you already have somebody on the problem. Maybe it's even fixed before you ever have any users that realize that something's actually failed. So when we get those reports in, what do we do with them? Well, in the old days, you wrote it down on a piece of paper and you ran out to fix the problem. And that was great until you tried to document those problems. Who was actually working on it? I don't know, it was the guy that took off with a note. What was the problem? I don't know, it was on the note. It was a real problem. Well, anymore you end up with what's referred to as trouble tickets, software that will document who called in the problem, who took the problem on the phone, what type of problem is it? Is it a software problem or a hardware problem or a network problem? So the nature of the problem, the types of hardware involved. And what will happen is, the more you document this, you develop a picture of what's going on in your network as various trouble tickets come in. So you can start to identify, is there a problem with a specific type of hard drive that you've been using? Is there a problem with a particular piece of software? Maybe we're not training users appropriately to use that piece of software, so we're getting a lot of these tickets in. What does that tell us? It tells us we need to do a better job of training our users on that particular piece of software. We can be proactive rather than reactive. but we have to have some way of documenting all that up front before we know what problem to attack. Trouble tickets allow us to keep track of the problems, who's assigned to them, etc., keep various statistics on them, prioritizing problems. I mean, we probably need to jump on that problem that our weighing connection is down if we're an e-commerce company before we jump on the CEO's game of Minesweep. It's just that's important to be able to prioritize certain problems. And then produce various management reports. If you're the network manager, you want to be able to justify why your department should get more money. We're doing a good job of managing trouble tickets. If we don't get an increase in our budget, the trouble tickets are going to go up. It's going to cost us X amount of dollars. The various statistics and various information that you'll accumulate through your trouble ticket system will create a trouble log. The purpose is to record problems that must be corrected and keep track of associated statistics. Again, if you start to see that specific hard drive has a problem, it means you don't buy those as replacement hard drives, network cards, switches, whatever it happens to be. So helpful reviewing patterns, problem patterns on the network can be used to identify which network components are the most problematic. And then they give you an example: 37 calls for software problems, 26 calls for modems, 49 calls for client computers. So it gives you an idea as a network manager where you need to spend most of your time, some of the problems that you need to attack. Performance and failure statistics. Main performance statistics, things like the number of packets moved on a circuit and the response time. This is really kind of hit and miss. Network managers have their own statistics that they think are important. It really is up to the prerogative of any particular network manager as to what they think is the most important, what they want to track. But certainly response time, responding to a ticket, that's a big one. Usually a lot of times managers want to keep track of how long does it take us to get out to a customer, to a client, to somebody that's in our organization, and help them with whatever problem that it is that they have. How long does it take us to actually resolve that problem? Those are things that are really important when we go back to management and say we need an increase in our budget. We need to hire more personnel. If our response time is really long, we're too busy. We've got problems. We need to hire more people. We need to do better planning. Certainly provides us a lot of insight and fuel with respect, or an argument with respect to management when we're asking for funding. Any questions yet? Failure statistics, availability, percent of time the network is available to users. Certainly if you're an e-commerce company, that's what you want to look at. We want to be at 99.99999, as many nines as we can get as possible, because when we're down as an e-commerce company, if we're not connected to the WAN, we're not making any money. All we're doing is spending money. So availability is a big deal. At the same time, once you fail, you want to reduce the downtime to as small as possible. So how long does it take to get back up and running? Some of those statistics that you're looking at, probably the most common one is the mean time between failures. Just if you purchase a particular hard drive or network card or printer or whatever it is, how long before it normally fails? It gives you an idea as to how often you probably ought to think about replacing that particular type of product in your organization. How many backups you probably need to keep. If you keep track of when you purchase that equipment, you've got a pretty good idea of what your replacement cycle should be for those particular items. Mean time to repair, once it does fail, how long does it take? If it takes a long time to repair a particular item, you probably want a backup in place. If it's something you can replace really quickly, it's not mission critical, if it's down a few days, no big deal, just order a replacement when it fails. But you've got to understand, you've got to know what those numbers are and what level of importance that those devices have in your organization before you can make that decision. Other daily statistics, number of errors per circuit. If you've got a lot of errors, you've probably got a cable that's running past an electrical circuit. You've probably got a cable that has some of the shielding that's been torn away, something like that. Volume of transmission per circuit. Maybe you need to upgrade that particular circuit. Maybe it needs to go from unshielded twisted pair to fiber optic, because there's a lot of demand for that particular circuit. Used to identify devices or circuits that have higher than average rates, thus they may be good candidates for upgrade. Used for predicting future growth patterns and failures. So you can kind of look at some of the stuff that you might be some of the information that you might be collecting about various circuits. In this case, they have 3 circuits that they're looking at and the performance of those. But the information that they're gathering, or the statistics that they're gathering on those circuits, is not in isolation. They're not just gathering statistics. They're also tying in with the statistics that they're gathering things that are actually occurring around those circuits, things that are impacting the performance of those circuits. So for example, on this one, circuit C had new hardware or software implemented here. So you see how that impacted. You can probably look at that and you say, oh, well, that new software or hardware had a real impact on the performance of that particular circuit. At the same time, this one over here, circuit B, moved to a new microwave channel. Well, that circuit was doing fairly okay, and ever since then it's been really high. The utilization of that circuit has been really high. We want good utilization, but we want to be able to meet all of our demand too. Maybe that microwave isn't performing up to par. Maybe we need more bandwidth. And then this last one just is consistently getting worse, getting worse, getting worse. Nothing's really appeared to happen to it. It just keeps getting worse. Probably a problem with the cabling. Maybe it's getting oxidation on some of the contacts or something like that. As far as improving performance, some of the things that you can do to try to do that really more from a managerial perspective. You can implement certain policies. You can use server load balancing, and you can use server level agreements. These are really more managerial approaches to be able to try to improve the performance of your network. With respect to policy-based management, it's the idea that not all the traffic that's going across your network is of the same importance. Video transmissions are more time-sensitive than email transmissions, for example. And policy-based management basically allows you to prioritize certain packets over other packets, to prioritize certain IP addresses over other IP addresses. So depending on the particular piece of software that you're using to implement this, there's there's very granular policies that you can really kind of drill down into. So for example, maybe you really want to make sure that CEO has access to Minesweep all the time. It's a network application that he can play against users and stuff like that. So you want to make sure he has access to that Minesweep all the time and prioritize his contact with his peers. You can do that. You can prioritize his IP address. Or you can say, no, video is more important. So you can prioritize those types of packets over other types of packets. So there's a lot of different things that you can do with respect to prioritizing one over the other. It depends on the needs of the organization. Realistically, you probably should not prioritize the CEO's communications, even if it's not Minesweep, just because most of the time what they're doing can always wait for just a couple of seconds. It's not something that's usually going to impact the performance of the corporation. At the same time, if that corporation happens to be performing e-commerce as their business, that's the core of your business. That's probably the traffic that you need to emphasize. Server load balancing. Server load balancing is the idea that we're going to spread the load across multiple servers, and that's going to allow those various servers to respond to a lot more requests as they come in. If a server happens to fail, it's just gone. We still have the remaining servers to service various requests. It allows part of our network to go down and yet still continue to function. Now, they don't actually give us a diagram here, but basically what happens is you end up with one computer that controls requests as they come in. The request comes in, it looks at, say, 5 different computers that are serving those requests, and it sends it to the first one. The very next one, it sends to the second one. The very next request, it sends to the third one. And it continues to do that in order to break up that load amongst those 5 computers. If that first one happens to fail, that first computer, that main computer, just stops sending requests to the first one and just continues to send it to those next 4. It's a very scalable approach. So as you tend to get busier as a corporation, you've got 5 computers, you want to add more capacity, add a 6th server, add a 7th server, add an 8th server. So it's very scalable. You can ramp it up or scale it back depending on the needs of your company. Now the downside to that is that one server, if it goes down, you might as well not have any servers. So in a lot of cases you want backup servers for that as well. Service level agreements are another way to try to manage the performance of your network. A lot of times you can push off some of your requirements onto a supplier, onto somebody that's providing you service. Whether it's WAN activity, your WAN connections, you can push it off onto them that they're going to guarantee you a certain level of service. That it's going to be 10 meg down 99.9% of the time. That if a connection happens to go down, they will respond within 30 minutes and guaranteed to have it back up within an hour. Various things that you can write into a service level agreement. The higher the expectations that you have for them, the more that service level agreement is going to cost. So keep that in mind. At the same time, it doesn't have to be service in the sense of WAN connectivity. It may be looking at your hardware. Maybe you bought an HP server. Maybe they've got 4 hours. Part of the service level agreement may be that they'll respond to a problem request within 4 hours. They'll have any problem fixed within 8 hours. They'll be on site within so many hours. So they can respond to hardware. You can have service level agreements with respect to hardware as well. So it just really depends on how you want to attack some of those performance issues. You can use a variety of different measures, and service level agreements are one of those. Another management function, end user support. Any questions? End user support. Solving the problems users encounter while using the network. They're going to have them. I mean, they forgot to turn it on. In fact, I think I have a video somewhere later in the semester. If you haven't looked it up already, look up Eddie Izzard. It's a good one. The whole skit, and it's all about just turning stuff on. The two main functions of end user support: resolving problems and end user training. That's where you're going to spend most of your time. As far as resolving problems, hardware failures, typically pretty easy because they kind of point to themselves. In a lot of cases you'll have a switch, especially if you have a lot of cheap switches in your organization. They fail. Better quality switches tend to last longer to the point that you typically have to replace them because of performance rather than failure. You need more ports or you need a faster switch. But cheap switches fail. And when they do, it's usually pretty easy to say, look, we don't have any connectivity into this room. All the rest of the building's up and going. Let's go check out the switch. And so they're relatively easy to find and diagnose, and hopefully you've got a backup. You can replace it and be back up and going. Software issues tend to be a little bit more troublesome because, especially the larger the organization, the less homogeneic your systems are. It makes it very hard for somebody in the help desk position to be able to know every piece of software and all the various details about those various systems. So that can be tough. So you spend a lot of time talking to users about what they were doing, trying to reproduce the problem, and see if you can't figure it out. Sometimes you can figure it out by trial and error, especially if your user happens to not be very computer literate. In other cases, they are very computer literate. They just happen to have a really weird problem. So you may have to spend time researching a problem with Google or the manufacturer's website, contacting their help desk, etc. So software problems can tend to be a little bit tougher. Process for resolving problems: assistance requested by the user from the help desk. That's kind of where it begins if it's a software problem, or software or hardware on their end. Trouble ticket is created and maintained by the trouble log. In some cases, you can get the problem resolved right then. They call in to register an issue, and if it's an issue that you've seen before because you've registered it in your trouble ticket system, or it's an issue that's maybe outside the purview of your particular network, but you're aware of the problem, they're already working on it, you can go ahead and report right then to the user, say, yes, we're aware of the problem, the people at AT&T are working on it, and we should be back up within the hour. You can give that information back to them right then, and that's the best case scenario. You want to be able to tell them right up front what's going on, and so it's nice to be able to have that. But in some situations you can't. It's an actual problem that they're having. And so if that's the case, then you actually have to start working on that problem. and you start running through this process here. Hopefully your help desk can resolve 80–90% of your problems. If they can, they're generally your first level of support. They're the ones that most end users see the vast majority of the time. And they've got some pretty good skills most of the time. They're able to take care of most of the problems. But every now and then, it's something that's a little bit different, has to kind of be bumped up the chain of command and talk to people with a little bit better training. And in some cases, again, you have to contact the actual manufacturer of the hardware, the software to resolve the problem, because it's just that weird of an issue. Providing end-user training tends to get overlooked. It would be my experience from a network manager's perspective. They tend to ignore it. They tend to kind of assume that users will take care of it on their own, or that they're going to read that documentation and those training manuals. They don't. But you do have other options, in-class and one-on-one instructions. Ongoing responsibility of network managers. What tends to happen in most organizations, if they provide training, what normally happens is they do it once and then kind of walk away. It's over. And that's fine for some things, but for other things you really kind of need to revisit them. Things like security issues, you need to periodically talk to users, because it's not a case of them not knowing, it's just a case of it not being in the front of their minds and remembering, oh yeah, I'm not supposed to share passwords. You would be surprised. Just reminding them of things like that is very effective. But when you don't remind them regularly, they tend to slide over time. Important to have ongoing training programs. Employees often change jobs within an organization and add new employees who require training. So it's not just new employees. People move within an organization. When they move within an organization, why are they doing that? It's a different job. Different jobs typically are going to require different access rights, different software packages that they're using, things like that. So training needs to occur not just for new employees, but also for employees that are changing jobs. Types of training, like I said, through documentation and training manuals, tends to not get done in class and one-on-one instruction. In class is really a good one to do if you can get away with it. If you can get the commitment from the organization to be able to do that, because we tend to have a better attention span when we show up in a class. We're all sitting there focusing on the problem at hand, and we're addressing the issues, we're learning about it. The downside is it's very expensive. Not only are you paying somebody from the help desk to do the training, or from wherever to do the training, you're also pulling people away from their normal job to be there for training. So it's kind of a double whammy. Not only is it an expense, you're also losing on income, whatever function that they're actually supposed to be performing. And then one that's very effective but very costly, one-on-one instruction. Really kind of for the same reasons. It has some of the same issues of this, but it's one-on-one now. So that person you're paying to do the class, that cost starts to add up because they're having to do it for each individual. That individual still can't do their work while they're being taught. On the cost side of things for a manager, one of their big concerns, costs from the perspective of our network traffic versus our network budget. We keep placing more and more demands on our network, but we're not giving them a lot more money over time. So it's a real problem for managers, and they have to be aware of that as they're planning the budget, as they're planning their network for the future. Some of the sources of those costs, the biggest one is just maintaining individual PCs. A metric that gets thrown out a lot is total cost of ownership, and this book actually does a pretty good job on this. Talks a little bit about total cost of ownership, tells you what it is, and then says why it's not a very good statistic. There's another statistic that's probably a little bit more appropriate. Total cost of ownership, a measure of how much it costs per year to keep one computer running. You hear that? The cost to keep one computer running for 1 year. According to TCO, $5,000 to $10,000 per year is not uncommon for an organization. Well, you can get a really good computer for $5,000. I mean, a really good computer. And then double that, because that's what it's going to cost to maintain it each year. It's the idea that once you set that computer up, you're not done. It's going to require upgrades. It's going to require maintenance. It's going to require new software. It's going to require updates. Parts of it are going to go down. The user's going to need help. all these various things add up costs. Every time it goes down, that user can't do their job function, can they? So that's a cost. And that's one of the weaknesses of total cost of ownership, that in the real world, that user doesn't sit there twiddling their thumbs. In the real world, they go to another computer, they do something else in order to not just be sitting there. At least you would hope they would. So that's the real issue with total cost of ownership. But it is an attempt to try to measure some of those hidden costs that exist with respect to supporting our computers. The other form of measurement is the net cost of ownership. It's the alternative to TCO. Some people call it the real TCO. It measures only the direct cost, so it doesn't worry about that wasted time by individuals. So it's an important distinction. Even with that, your support costs are still pretty high. $1,500 to $3,500. You can get a pretty good computer for $1,500. So double that, and that's per year. The largest network budget items, with using NCO as the metric, personnel costs. Those people that are supporting our systems, 50 to 70% of our costs. In the mainframe days, we had very few individuals, and our hardware was very, very expensive. That dynamic has shifted to where we're spending a lot of our money on personnel now, over half. The next one is WAN circuits, and then hardware upgrades and replacement parts. What does that tell us? We need to focus on our personnel costs. How do we do that? So it kind of gives you a breakdown of some of those costs where we're spending our money. How do we focus on our personnel costs? How would you go about reducing some of those costs? Think about that for a second. Any ideas?
Group training.
Pardon?
Group training.
Training's certainly a good one. The better they are at solving a problem, the quicker they can solve it. Hopefully you require fewer personnel. If you standardize on equipment, they got the same equipment, the same software throughout the organization, again, you're going to get better at resolving the problems that pop up with those. If you have everything under the sun in your organization, you're going to have a lot of people. You got to support a lot of stuff. So managing a network budget is difficult, especially for network managers. Why? Because most network managers come from a technical background. They're used to dealing with computers. They're not really much of a people person to a large degree. They don't like running numbers. They don't like the finance/accounting side of things. And that's an issue, because that's at that level for the network manager's position, that's really a requirement for that position. Some organizations have tried to implement a chargeback policy in order to counter increasing costs. It's basically running the network department as its own organization, as a profit center, rather, not really a profit center, but not as a cost center. So essentially they're charging various departments for access to their services. It's hard to do in a networked environment. It can be done. There are examples of it being done successfully, but it's hard to do. And it's something that's really kind of a holdover from the old mainframe days when that was done with a lot more success. But it is something that can be done if your particular organization requires it. Going back to that reducing costs, develop standard hardware and software configurations. If you see the same problem, same software over and over and over again, you're used to the menu. You know where everything's laid out. You can solve a lot of problems that you've never seen before just because you're so familiar with the software. Same thing with hardware. Easier to diagnose and fix those problems, easier to learn. Automate as much of the network management process as possible. Being able to push out those software updates, if you can automate that. Automating virus scans and virus definition updates, automate that. Automate your backups. Automate your addressing with the HCP. There's a lot of things from a network manager's perspective that you can automate and will really help make not only your life easier, but it'll also end up with a more consistent application of those various things across your network. Why? Because the computer doesn't forget to back up that computer. Once you've told it to back up that computer, it's going to back it up every time, unless there's some kind of an issue. So you need alerts to be thrown when issues pop up, so that they raise the attention of the network manager. Reduce the cost of installing new hardware and software. Sometimes you can pay your vendors to go ahead and configure things before you get them. Well, if you're purchasing a lot of stuff from them, in some cases it might be cheaper to pay them to do it rather than to wait to get it and actually configure it yourself. Centralized help desks, not only can you save money because of that, you also probably end up with a better understanding of the failures, the problems that are occurring in your network, because you've got one place, one centralized location where all this information is coming into. So you can do a better job of analyzing that information. Evaluate the move to thin client architectures. Personally, I'm not a big fan of thin clients, but there are definitely applications. Everybody know what we're talking about when we talk about thin clients? There's this concept of a thin client versus a thick client. And when you're talking about the traditional networked environment, we usually have thick clients. A thick client is a PC that's sitting in front of you, has a hard drive, has a motherboard, has memory, has everything that you need to be able to function on its own. You unplug the network card, and other than network access, you can still work on your Word documents, Excel documents, all those types of things. Now, when we say thick client versus thin client, it's not like there's one or the other. There's ranges. But the more of the processing power that we shift, the more the capability that we shift away from the client and back to a server, it starts to become a thin client. So that if we actually unplug the network cable, we may not be able to do anything on a particular machine. So on a particularly thin client, it may be nothing more than providing screenshots to you. So there's no processing capability in terms of being able to do any kind of analysis or anything like that. There's no hard drive, there's no local storage or anything like that. It's literally just screenshots. So probably a good example of something like that might be an ATM machine. That ATM machine doesn't keep track of your bank account, who you are, or any of that type of information. It's linked back up with a network somewhere else. You unplug that connection, that ATM won't do anything. So that's the difference between a thin client and a thick client. The reason it helps you to control costs in a thin client architecture, or in a thick client architecture, when you have an update that comes out, you've got to update all those various machines. Well, if you don't have some kind of electronic software distribution software, you're going to have to go out and physically touch all those machines. You've got to work with all those physical machines. Even if you have something like that, what happens when you have hard drives that fail? You've got to go out and replace those hard drives. All those hard drives cost money in the first place. Additional costs on those thick clients. In a thin client architecture, they don't have hard drives on those local machines. All they are is really screenshots. If we have to do an update, we don't need an ESD, any type of electronic software distribution. We make the update back at the central server. Those screenshots are automatically sent out to those various thin clients from there. So it can be a very cheap way of doing things. But again, the network goes down, it's not one machine that's down, everything's down. They can't do any work at their local machine. So there's pros and cons to both approaches. But in some instances, it's a good way to manage costs. Network implications for management. Having a good understanding of networking technology as a network manager. You have to. You're dealing with technical people. That doesn't mean as a network manager that you have to know everything about networking. You don't have to be overly technical. But you need to be somewhat technical so you understand what your network administrator is telling you, what the people in your help desk department are telling you, so you can communicate with them. At the same time, you need to have people skills so you can talk to end users. You can spend a lot of time talking to end users, trying to calm them down and not kill your support staff. At the same time, you also have to be able to talk the language of who? Your bosses, CEOs, CFOs, COOs. So you've got to be able to talk with a variety of different hats on. And an understanding of key elements driving network costs. You've got to have that understanding of finance and accounting as well. So it really requires a special skill set to be able to talk to the higher-ups as well as the people that are on the line, because you are talking about different apples and oranges as far as what their concerns are. Higher-ups are concerned about costs. The people on the line are really concerned about, I want this computer to work so I can do my job. Network management increasing its complexity, it's just going to continue to get more and more complex. Why? Because we keep demanding more and more of our networks. We throw more and more services on it. We want video. We want to be able to access Netflix. We want to be able to access various things that are just requiring a lot of bandwidth, and That makes it that much more complex, and that means we have to keep developing staff. We have to hire more staff. They have to be better trained staff. They have to be more expensive staff. So that is that chapter. It's a good chapter. I like that particular one. It could be better. It's not they don't cover everything in there. They don't cover change management all that well, but it's a good chapter for you in terms of your groups at this point in the semester to start thinking about your projects. And when you start trying to formulate ideas for it, go back to this chapter and look at some of the important things that they're talking about. Those are some of the key things that you want to include